the earth shudders. California drowns under relentless rains, houses swallowed by mudslides. Meanwhile, Australia bakes, wildfires turning the sky blood red. Half a world away, the Amazon withers, the lifeblood of the planet choked by drought. These are not scenes from a disaster movie. This is the new reality of a world grappling with the dramatic effects of El Niño and La Niña. These seemingly exotic names, whispered in hushed tones by meteorologists, have become synonymous with climate chaos. But what are El Niño and La Niña? They're not storms, not hurricanes, but rather powerful climate patterns that originate in the vast expanse of the Pacific Ocean. They are the puppet masters of global weather. They're invisible strings tugging at the atmosphere, dictating droughts and floods, heat waves and blizzards across the globe. El Niño and La Niña are two sides of the same coin, the yin and yang of the Pacific Ocean. They are part of a natural cycle, a delicate dance between the ocean and the atmosphere. But as the planet warms, this dance is becoming increasingly erratic, the music more frenetic. Understanding these phenomena is no longer a matter of scientific curiosity, but a matter of survival. Because in a world on the brink of climate change, knowledge is power and preparedness our best defense. Imagine the Pacific Ocean as a giant bathtub stretching from the Americas to Asia. This vast expanse of water plays a crucial role in regulating the Earth's climate. The Pacific Ocean is not just a static body of water, it is dynamic and constantly in motion, influenced by various atmospheric and oceanic processes. Now imagine a giant seesaw in the middle, one end dipping into the warm waters of the Western Pacific, the other into the cooler waters of the East. This seesaw represents the delicate balance of ocean temperatures and atmospheric pressures that drive weather patterns across the globe. This, in essence, is the El Niño Southern Oscillation, or ENSO, the climate pattern that governs El Niño and La Niña. ENSO is a complex interplay of oceanic and atmospheric conditions that can have profound effects on global weather. In normal years, the seesaw remains balanced. The trade winds blow steadily from east to west, maintaining a stable climate system. Warm surface waters pile up in the Western Pacific, driven by trade winds blowing from east to west. These winds push the warm water towards Asia, creating a pool of warm water in the Western Pacific. This creates a pressure difference, with lower pressure in the west and higher pressure in the east. The pressure gradient is a key factor in maintaining the trade winds and the overall stability of the climate system. This pressure gradient helps to maintain the trade winds, creating a feedback loop. The stronger the trade winds, the more pronounced the pressure difference, and vice versa. But every few years, this equilibrium is disrupted. The seesaw tilts. This disruption can be triggered by various factors, including changes in ocean temperatures and atmospheric conditions. During El Niño, the warm waters in the Western Pacific slosh eastward, like water in a bathtub. This movement of warm water towards the central and eastern Pacific disrupts the normal climate patterns. This shift in warm water alters the atmospheric pressure, weakening the trade winds. The weakened trade winds further exacerbate the movement of warm water, creating a positive feedback loop. The result is a cascade of changes in weather patterns across the globe. El Niño can lead to extreme weather events such as heavy rainfall, floods, droughts, and even hurricanes in different parts of the world. La Niña, on the other hand, is El Niño's cooler, calmer sibling. It represents the opposite phase of the ENSO cycle, characterized by cooler-than-average sea surface temperatures in the central and eastern Pacific. During La Niña, the seesaw tilts in the opposite direction, intensifying the normal conditions. The trade winds strengthen, pushing warm water even further west. The trade winds strengthen, pushing warm water even further west, and drawing up cold water from the depths in the east. This upwelling of cold water brings nutrient-rich waters to the surface, supporting marine life. This creates a stark temperature contrast across the Pacific, with significant impacts on global weather. La Niña can lead to cooler and wetter conditions in some regions, while causing droughts in others. Both El Niño and La Niña are powerful reminders of the interconnectedness of our planet's climate system. Imagine stepping into the Pacific Ocean during a scorching summer day. The sun is blazing, the sand is hot beneath your feet, and you eagerly rush towards the water, expecting a refreshing dip to cool off. The water, usually refreshing, feels unusually warm, almost bathtub-like. It's a surprising sensation, one that hints at something unusual happening beneath the surface. This is the hallmark of El Niño, a Spanish term meaning the little boy, a reference to the Christ child, as this warming typically peaks around December. El Niño events are part of a larger climate phenomenon known as the El Niño Southern Oscillation, or ENSO. Officially, El Niño is declared when sea surface temperatures in the central and eastern tropical Pacific Ocean rise 0.5 degrees Celsius, 0.9 degrees Fahrenheit, above the long-term average for at least 3 consecutive months. This seemingly small increase in temperature can have profound effects on global weather patterns. But El Niño is not just about warmer water, it's about disruption. The warming of the ocean's surface alters atmospheric circulation patterns, leading to significant changes in weather across the globe. This seemingly small increase in temperature has a domino effect on the planet's climate system, triggering a chain reaction of extreme weather events across the globe. These changes can lead to severe consequences for ecosystems, agriculture, and human communities. From torrential rains and floods in some regions to crippling droughts and wildfires in others, El Niño's impacts are far-reaching and often devastating. Coastal areas may experience severe flooding, while inland regions might suffer from prolonged dry spells. Now imagine diving into the Pacific and feeling a chill run down your spine, the water surprisingly cold. The stark contrast to the warm waters of El Niño is immediately apparent. This is La Niña, Spanish for the little girl, a stark contrast to her warmer counterpart. La Niña events are also part of the ENSO cycle, but they bring about cooler than average sea surface temperatures. La Niña is characterized by cooler than average sea surface temperatures in the central and eastern tropical Pacific, a drop of at least 0.5 degrees Celsius below the long-term average for 3 consecutive months. This cooling effect can also lead to significant changes in global weather patterns. La Niña might sound milder, but don't be fooled. It packs its own punch, unleashing a different but equally disruptive set of weather extremes. The cooling of the ocean surface can intensify atmospheric conditions, leading to powerful storms and other severe weather events. From intensified hurricanes in the Atlantic to heavy snowfall in North America, La Niña's impacts are just as significant as El Niño's, though often manifesting in different ways. These events can disrupt lives, economies, and ecosystems, highlighting the profound influence of the ENSO cycle on our planet. The drama of El Niño and La Niña unfolds on a grand stage, the vast expanse of the Pacific Ocean. This immense body of water, covering more than 63 million square miles, is not just a passive player but an active participant in the Earth's climate system. It is here, in this vast blue expanse, that the intricate dance of atmospheric and oceanic forces takes place, shaping weather patterns and influencing climates across the globe. But the unsung heroes of this climatic saga are the trade winds, those relentless breezes that blow predominantly from east to west near the Earth's equator. These winds, though often overlooked, play a crucial role in maintaining the delicate balance of our planet's climate. They are the invisible hands that guide the movement of warm and cold water across the Pacific, setting the stage for the dramatic climatic events we know as El Niño and La Niña. These winds are the invisible conductors of the ocean atmosphere orchestra, regulating the distribution of heat and moisture across the Pacific and influencing weather patterns worldwide. By driving the surface currents, they help to distribute the sun's heat from the equator towards the poles, ensuring that no part of the planet becomes too hot or too cold. This delicate balance is essential for sustaining life on Earth. In normal years, the trade winds act like a giant broom, sweeping warm surface water westward across the Pacific. This movement of water is not just a simple flow, it is a complex process that involves the interaction of various forces, including the Coriolis effect, which causes the water to veer to the right in the northern hemisphere and to the left in the southern hemisphere. This westward flow piles up warm water in the western Pacific, creating a deeper layer of warm water known as the warm pool off the coast of Indonesia and Australia. This warm pool is a critical component of the Earth's climate system, acting as a massive reservoir of heat and moisture that can influence weather patterns far beyond the Pacific region. This warm pool acts like a giant radiator, releasing heat and moisture into the atmosphere, fueling the monsoon rains that sustain billions of people in Asia and Australia. These monsoons are vital for agriculture, providing the necessary rainfall for crops that feed a significant portion of the world's population. Without the influence of the trade winds and the warm pool, these life-sustaining rains would be far less predictable and reliable. During El Niño, the trade winds weaken, like a tired conductor struggling to keep the orchestra in sync. This weakening disrupts the normal flow of water and heat across the Pacific, leading to significant changes in weather patterns. The once strong westward push of warm water diminishes, causing a cascade of climatic effects that can be felt around the world. This weakening allows the warm water piled up in the west to slosh back eastward, reducing the temperature difference between the East and West Pacific. This shift in water temperature can lead to a variety of weather anomalies, including increased rainfall in some regions and droughts in others. The impacts of El Niño are far-reaching, affecting everything from agricultural productivity to the frequency and intensity of tropical storms. As the warm water spreads eastward, so does the region of rising air and increased rainfall, disrupting weather patterns across the globe. This redistribution of heat and moisture can lead to extreme weather events such as floods, hurricanes, and heat waves in regions that are not typically affected by such phenomena. The global nature of these impacts underscores the interconnectedness of our planet's climate system. La Niña, on the other hand, is like a strict conductor demanding more from the trade winds. During La Niña events, the trade winds strengthen, blowing even more forcefully from east to west. This intensification of the trade winds has a profound impact on the distribution of heat and moisture across the Pacific. During La Niña, the trade winds strengthen, blowing even more forcefully from east to west. This increased wind strength enhances the westward movement of warm water, leading to a more pronounced warm pool in the western Pacific. The stronger trade winds also promote the upwelling of cold, nutrient-rich water along the eastern Pacific, particularly along the coasts of South America. This intensifies the piling up of warm water in the west and strengthens the upwelling of cold, nutrient-rich water along the coasts of South America, further amplifying the normal conditions and their associated weather patterns. The cold, upwelled water is rich in nutrients, supporting a diverse and productive marine ecosystem that is vital for the fishing industries in these regions. Thus, the trade winds, through their influence on ocean currents and temperatures, play a crucial role in sustaining both terrestrial and marine life.